Welcome to the satellite communication course. Today we start here a next model, that is satellite navigation system and a GPS system. So now in which we will learn that various navigation system and we'll compare those navigation system, and then we learn that what will be the GPS position, means GPS position location principle, and then we learn that a GPS receiver and a differential GPS there. So before start with understanding of a navigation system, so we should know that what is the principle behind the satellite navigation system, and then why these navigation systems are used. Now if you see that in navigation, it is used to see that finding the position or a location of an object, and then from once we obtain the location or a destination there, then using that we can reach to that particular destination there. So means there are the various ways for the navigation. So in old days, people have used a compass for the navigation, so we can find out the east west likewise, or based on that direction of a present situation of a sun, and according to that we can obtain that a direction there. So there are the various components that was used earlier days, old days. Then there were various meters available to obtain that navigation path or a location there. So in the case of electronic navigation, so we can use a various methods that for the navigation, that is a LORAN, means it is nothing but what, a long range navigation. Then we can say that a sonar, so in which we can say that sound range navigation or sound navigation ranging there. And then we can say that a radar, we can say that radio detection and ranging. Now these are the electronic navigation system that are used to identify the position of a ships or position of the aircraft there. But if you consider that in terms of measuring the timing and all, so we need to see that for the
Hi.
timing measurement.
Uh,
Now we continue here to see that what are the navigation system. So now that LORAN, sonar and radar, these are the navigation system used in a electronic navigation, used through the electronic navigation there. And this one we just find out what is the position of the given object there. Then we need to find out again accurate timing measuring instrument, so that we can easily obtain the position of that particular object, and then what will be the timing required for that particular position to send the signal or to reach that particular place. So that's why we need to know about that a timing component. And the timing component, if you see that there were various clocks used, and that clocks are used to measure the timing accurately there. So then another method for the navigation. So earlier days, people have used that gyroscopes for the ship and aircraft there, and then through that they can find out the direction or a position there. Now, in the case of a satellite navigation, so satellite is moving around the Earth, and then we need to find out the position or location of ourselves using the satellite navigation system. So now position, we need to know about what will be the distance between that satellite and ourselves there, or you can say that a distance between that a transmitter and a receiver. So we will get the position, and for that purpose we need to know about that what will be the timing for that sending the data from the transmitter to the receiver. So we should know that accurate timing. So in the satellite navigation system, we can go for the finding the accurate position and timing anywhere on the earth. So that's why a satellite navigation system, so people are saying the name that is a global navigation system, GNS. So you can say that we have that a GNSS, global navigation satellite system. Okay, that is about a GNSS. And that will be used to obtain the position there. Now then, if you see that there are the various navigation system that was developed or that was designed in the world there, and people are using the various navigation system, and then for those navigation system, so people are using that country, they have their specific navigation system. So if supposed to be, we take the example of the US, they have started the global positioning system, that is about a GPS there. And then in that GPS system they have a 24 satellite that are operating to find out the position of the object there. So similarly, if you see that other countries, GLONS, okay, so there are the various countries, they have their own navigation system. And if you see that India, we are using that a GPS navigation system. So now what is the principle behind that navigation system, that we'll learn here, and then how that satellite navigation takes place, that we'll see here. So we should know that what is the principle behind the navigation system. Okay, principle of a navigation system here. We will learn that. Now in that case, if you see that we have the a one particular object in a earth suppose, and we need to know about the position of that particular orbit, that particular object there. So at any instant of time, we should know that what is the position, what is the position with respect to the some certain references there. So that's why we need to send one particular signal from, suppose if it is a satellite navigation system, we can say that we need to send the signal from the satellite to that particular object. So means we can say that to obtain that particular position, so we need to use a transmitter, and then a transmitter is somewhere at some particular position we supposed to be consider that, and then we need to communicate to this transmitter. So then we have a receiver, and then receiver at some particular place. Suppose we say that a transmitter at plate A and the receiver is at place X there. Then transmitter transmits some signal and receiver receiving the signal that will be transmitted from this transmitter there. So then we can calculate that the distance of the signal transmitted from the transmitter from this particular location there. So if we know that a time taken by transmitted signal for transmitting the signal from this place to this place here, then we can find out the distance from the transmitter from our location. So we should know that at what time that signal is transmitted here, and we need to know about what will be the delay. If means we can say that delay between the two device, it is depending upon that a distance there. Suppose I am saying that it is a near to transmitter and receiver are nearer, the delay will be small. If the transmitter and receiver will be at a large distance there, then there will be a large delay. So that's why we need to know about that the delay, and that delay can be calculated what exactly at exact instant that signal is transmitted, and at what exact instant that signal will be received by the receiver. So means we know that at what instant we are transmitting the signal, and suppose if we know that a exact instant of a transmission, then we can measure the arrival instant, and that arrival instant we can measure using the a local clock that is at the receiver there, and then we can calculate that what will be the delay. So that's why the distance of the transmitter from this location, this is about a position, distance of the transmitter from this particular position here, that is supposed to be, we say that a distance supposed to be r1 now, and distance between that we say that the transmitter and receiver, that is about r1, and then we're supposed to send one particular signal from this transmitter to the receiver, and for that we're supposed to consider that a speed of a signal, that is c is equal to 3 into 10 to the power 8 here, and then a timing here. So timing at one particular instant that signal is transmitted by the transmitter. So supposed to be say that is t1 is the time when signal is transmitted, and here we are receiving the signal at a timing t2, and then difference between that this particular timing, suppose we say that is a delta t here, so that we can calculate the distance between this transmitter and the receiver. So we can say that r1 is equal to what will be the difference between this timing t2 minus t1 into the speed of the signal, or we can say that a delta t to see. That is about the difference between this timing. For this R1, we say it's supposed to be a delta T1. So means we can calculate that a R1, that is the distance from the transmitter to the receiver. So that's why we can find out a what will be the range. Okay, that R is nothing but the range between this transmitter and a receiver there. So R1, we can say that that is nothing but the distance between the transmitter and receiver, or we can say that that is nothing but a range between these two particular devices. So now we see here. So what will be the distance we have calculated? But this distance we have calculated with respect to one particular transmitter. So in that particular case, we could not locate that a position of the receiver on the map, because we should know that where is the position of the transmitter, and that's why we doesn't know that what is the exactly location there. So here we are just obtaining a distance between the transmitter and receiver, but we are not obtaining anything regarding the direction. What is the position or what is the direction of that particular transmitter and receiver? Here is just distance. Now transmitter and receiver is there, but where is the position of that particular transmitter? We are not able to get it. Okay, through this. So we just obtain that only the a distance between that a transmitter there, and then from that we could not say that what is the exactly position or location of the receiver there in a given particular plane. So where is that particular receiver? We are not exactly we are not able to exactly obtain that. Now then we need to find out what is the position or a location of that particular object or a position location on a plane by using the various transmitter there. So we should note that one particular reference receiver we should have, then and then we are able to obtain the distance there. Suppose we supposed to consider that we have a one transmitter, and then one transmitter is at position, this is about a transmitter position A here, and this one is about a location of this given object, that is about X here, and we need to find out the distance between the from transmitter to the receiver. So this is about R1. So now we need to just draw a circle with radius R1 here. So that's just like we have seen that we have a transmitter and receiver, this is about radius. So now where is that receiver? We doesn't know, but we just find out this is about a position now because we are receiving some particular signal. But where is the transmitter? We doesn't know. So according to the distance between these two, so we can draw some particular radius. So similarly here we need to draw a circle with the radius R1 from the transmitter. So here in the case of we supposed to be consider there is only one transmitter, and then A here, and this one is about a receiver, and just we can say that is about a at this particular X position. This is about a condition is about what? A one transmitter. Now if we have a another transmitter there, this position location from the another transmitter, this one is about A is about one transmitter, and another transmitter. So now this was supposed to be a B here. And so this one is about a distance R1, and this one is about a distance a R2 here. Now this is about a condition. We have a two transmitter. So now in this particular two transmitter, if you see that we draw a radius circle of a R1 here. Okay, this is about a circle of radius R1. Another circle which has a radius R2 here. So we can find out that R1 and R2, and that R1 and R2 from the your transmitter. This is about your transmitter X. So that sorry, this is about our receiver. A is a transmitter, B is a transmitter. So we can find out the X, that a location of a receiver on this map is nothing but the intersection of this two circle. Okay, intersection of this two circle. So that is about a point here. So two circles are intersect at this particular point. So we just able to obtain that a position of that receiver on this particular intersection. So now we just obtain a 2 points here, but we are not able to obtain that X from A or X from B. Okay, so now we can say that we should have the another a transmitter at a known location. Then we can find out the distance between this that particular transmitter and our location. I'll say that I'm just trying to draw a circle. Okay, so it's supposed to be say that this is about another circle. Okay, so now this is about A B A B and a C, and this one is about the range. Here we have the X. We can say that R1, R2, and a R3 here. So that is about these are the three transmitter. We have the ABC transmitter, and we have the circles of R1, R2, R3. Now, if you see that the position or a location of this X means receiver, again we are not able to get on at what location there. We just say that there is a location of this particular X receiver. So in that case, we should know that what will be the location of this particular three transmitter, and then we are getting only the range. We are just getting the distance from this particular X here. Now, if you see that on the plane, this is about a three transmitter. We are just able to find out that what will be the a position of this particular uh, place or location here. That is about our location, supposed to be receiver as a location here, and from that A, B, C, these are the three transmitter here. Now this intersection of these three, all these three circles, that will provide the what is the position. Okay, what will be the position? So that's why we need to find out our location on the map. So we require here a three transmitter, and we need to know about the distance from this our location to the a transmitter here. So means we can say that there are the three transmitter on a one particular plane. So similarly we have a receiver that is lie on that particular plane. Then we are able to obtain that. But in the case of a satellite system, it is not a plane system. That is not a. It is not that receiver is not available in a specific plane there. So then we need to find out a distance of that particular location from the transmitter, because that in a satellite navigation system, so it is not in a single plane. That location of that object is not in a single plane. It will be in a spherical surface or a sphere here. So now we can find out the position or a location from the different point position, different position, or from the different views in that particular position there. Okay, with that different way we need to find out. So now here we have see that there are the multiple transmitter, so we can obtain the a position. Supposed to be, if we consider that a sphere now. Okay, so instead of that a surface, and then we supposed to be consider that instead of in a one plane, this is about a sphere now. And there in that case, surface of a sphere with radius r1, surface of a sphere with radius r2, surface of a sphere with radius r3 likewise. So point of intersection of that particular circle, so we'll get that a location here because of the point of intersection. So now we can say that we have the R1, R2, R3. These are about the three different ranges. Suppose we consider that there are the two transmitter, and and we know that distance of the location from X to the transmitter here. So if we consider supposed to be third transmitter here on that particular sphere, that we can find out that R3. Okay, radius on that sphere with radius R3 there. And then that intersection of these 2 points here at that particular point, then we can find out that which are those 2 points here from this transmitter there. Okay, so that is about a position there. So position of that receiver, it can be a fixed. Okay, there is about this about a position of a receiver. So it will be a fixed from the three transmitter. If supposed to be, we say that there is a satellite, the transmitter is supposed to be considered as the three satellite there. So now we can find out the position of the receiver at any place. Okay, So now that is about a satellite is in space now. Okay. Now it's supposed to be these are the three transmitter or the three ABC is nothing but a three satellite. And from that satellite, we can find out the position of the receiver at any place on the earth here. Means we can find out the position of the satellite. Okay. We can find out the position of that a receiver. So we can find out the a location. If we know the position of the transmitter, if we know the position of the satellite, then we can able to obtain that what will be the location there. So that's why in the satellite system, so they are using the if, to obtain the position of the satellite. So we need to use that the Earth centric Earth fixed coordinate system. Earth centric Earth fixed coordinate system. That is about it. ECEF. Now Earth centered Earth fixed coordinate system. If you see that this one is about a center of the Earth. This to be considered, and we supposed to be consider that this one is nothing but the sphere here. This one you can say that center of Earth. Okay. This one we say that the north, y, x here, z is about x here. And from this we supposed to say that this one is nothing but the equator. Say that from this to this, you can say that prime meridian. Okay. So this is about a Earth centered Earth fixed coordinate system. So if you see that it has a because it is just Earth is about a sphere now. So that's why we have this a three axis system, and that a three axis system because we consider supposed to be that ECEF coordinate system that will be described using the three orthogonal coordinates. That three orthogonal coordinates means x, y, z both are perpendicular to each other there. And here we supposed to be consider that this is about the center of the earth. Okay, for this particular coordinate system x, y, z with the origin supposed to be considered that a center of the earth. And that in this particular case, the z axis is directed from the center of the earth toward the north. Okay, this is about toward the north pole here. Okay, that's why we can say that a north here, z axis toward the north pole. And then we have the x and y axis. This is about x and y axis are on the equatorial plane. Then x axis passes through the prime meridian. This is about a prime meridian here. And the y axis passes through this 90-degree east latitude. Okay, we can say that this is about the ECF coordinate system. That ECF coordinate system that will be rotate along with the earth there. Now using this coordinate system, so we can describe the position of the object easily. Suppose we say that earlier that there are the three transmitter. So instead of that three transmitter, we supposed to say that we have the a three satellite ABC, and we know that the position of that three satellite ABC here, and that will be described, that ECF coordinate describe that satellite and a location. Look, that location of that is a nothing but what, from the satellite to the object. Okay, means that object is nothing but a receiver now. So if supposed to be there are the three satellite ABC here, we can say that three satellite, that is A, B, C, and for this ABC satellite, we can describe that position of that ABC satellite using that ECF coordinate. Now that we can say that for the position of satellite, we say that x1, y1, z1. For this B, x2, y2, z2. For this C, x3, y3, and z3. That is about the position of this a satellite. Okay, means we say these are nothing but a transmitter here. So instead of that, we say supposed to be these are about a three satellite. The position of these three satellites that can be described by this ECEF coordinate system. And here we can say that ABC satellite and their position are described by this ECF coordinate system. That is, we can say that we have x1, y1, z1 there. Okay, nice. This is about similarly x2, y2, z2, x3, y3, and z3 there. And then we need to know about position of the receiver. Suppose we say that if we have a receiver, okay, and that position of that receiver supposed to be, we say that that will be described by this ECEF coordinate system, and that will be what, receiver XR, YR, and a ZR. So then we can write the range equation of the that three satellite there. Means we say that a R1 is equal to what? Means that is about a R1 is about a range of the one satellite one, so X1 here. So with respect to the receiver. So R1 is equal to what? Under root of X1 minus XR bracket square plus Y1 minus YR bracket square plus Z1 minus ZR bracket square. Similarly, we can find out that R2 X2 minus XR bracket square. Then we can say that Y2 minus YR bracket square plus Z2 minus ZR bracket square. Then a R3 X3 minus XR bracket square Y3 minus YR bracket square Z3 minus ZR bracket square. So now these are about the R1, that is about the R1, R2, R3. These are nothing but the range equations or range measurement from the satellite to the receiver there. Means we can say that suppose we have the a satellite here, A, then we are transmitting. That is nothing but a R1. So similarly, we have the R1, R2, R3. that are the ranges measurement from the your satellite with respect to the receiver there. So here we have considered that a coordinate system of the satellite and the coordinate system of the receiver here. And then we obtain that what will be the range of the equation. But now we need to know about that. This is just like it is just showing the a range here. Okay, now from this R1, R2, R3, whatever we have calculated, now we say that here we have calculated that a range of this range equations of this three satellite with respect to the receiver or from the receiver. But that is just like we just obtain the range here. But in the case of a satellite navigation system, so we should know that for this given range equation, so here we say that R1 is equal to what? T2 minus T1 into C. So similarly, in the case of a satellite navigation system, one reference satellite is to be used. Okay. And that reference satellite that will be useful for the finding out the pseudo range here. So we consider that what will be the pseudo range equation using the a fourth satellite. That is about a pseudo range. So till now we have just calculated what will be the receiver range. Now